Hey everybody, nice to see you back to Math 20-1. We are going to be continuing with Lesson 6, Solving Equations Graphically. Now to get started, let's get some of those basic algebra skills going, and we're going to start by solving these three equations for x. And what I mean by solve is isolate the x. So let's go. For number 1, when we have x plus 5 equals 0, to isolate the x, we're going to do the opposite of adding the 5, and we're going to subtract it. So that gives us x equals negative 5. And we can always check by substituting back in. Now, this is a fairly basic one, but let's move it up to the next one of x squared minus 4 equals 0. Now, I want you to take a moment and pause right here. Pause the video and solve this one yourself. And come back and we're going to talk about the solutions. Well, coming right back here, we're going to do the same idea as we did for number 1. We're going to do the opposite of subtracting 4 and add 4, which leaves us with x squared equals 4. And most people realize that we have to take the square root of this. You might remember doing this when we're solving for Pythagorean theorem. So we take the square root of this and we get x equal. But the thing people forget is we really need to consider the plus and minus. And the plus and minus here is plus or minus 2. And you're thinking, well, why do we need plus or minus 2? We'll come back to that in a quick second. Let's look at 3. For 2x squared minus 18 equals 0, well, same thing. We're going to start by adding 18 to both sides. Get 2x squared equals 18. Now, the opposite operation here is divide because the 2 is multiplied to x squared. So we get x squared equals 9. And now we're kind of where we were with question 2. We're taking the square root of x squared, and we're going to take plus or minus the square root of 9. So x equals plus or minus 3. Now, the reason we need to do this is because both of these will actually work. For instance, if I take negative 2 squared minus 4, that's the same thing as saying 4 minus 4, which equals 0. And notice the same thing works if it's 2 squared minus 4. That also equals 4 minus 4, which equals 0. So from now on, even if you continue into Math 30-1, whenever we take the square root to isolate an x, we have to consider the plus and the minus. So let's keep going. So let's look at quadratic function versus quadratic equation. Now, so far, what we've actually been doing is we've been looking at quadratic functions. And a quadratic function, or any function that is, generally, it's a rule. It tells us what happens to an input value x and get that output value. So it's the rule of what happens to x when you put it in to spit out the output. However, quadratic equations are a little bit more specific. They actually tell you a specific value of y at some specific value of x, though we don't usually know what that x value is. And then we're asked to determine it. For example, here we have a quadratic function where y equals x squared plus 3x minus 4, and we can pick any value of x, do a little calculation, and it spits out the y. So in other words, we can determine y for a certain value of x if we plug it in. However, the quadratic equation's a little different. Notice here we've replaced the y with 0. Now, this is a specific equation where there's only one unknown, and that's the x. So now what we want to do, we want to determine what values of x make this true. In this case, x minus 4 and x equals 1 are valid. And let's go ahead and show what we mean by valid. For instance, we know that the left-hand side of the equation is 0. And the right-hand side of the equation is x squared plus 3x minus 4, but we're going to substitute in that value of 1. So this gives us 1 plus 3 minus 4. Well, that's 4 minus 4, which is 0. So the left-hand side equals the right-hand side. So that's a valid value of x that makes the statement true. And if we tested the same for x equals negative 4, we would find that also would be the case. So what does it mean to solve an equation? Well, let's go through this example here, and hopefully things will become a little clearer. So consider the function y equals x squared plus 2x minus 3, and the graph of this is shown to the right. Now this is a pretty basic thing. It's a state the x-intercepts. Fair enough. So we find this x-intercept and this, and as an ordered pair, we could say, well, one of the x-intercepts is negative 3 and 0, and the other one is 1 and 0. And by definition, we know that an x-intercept is the point, so in a point is an xy value, just to be sure, where the line or curve crosses the x-axis. Now let's go to part B, where it says substitute these values of the x-intercept into the equation. What they mean by that is the x-coordinate into the equation of f of x. What do you notice? So let's go ahead and do that. I'm going to scroll up a little bit. So what we have here, we're going to say f of negative 3, that was the one on the left-hand side, and we're going to substitute that into the equation. And that was x squared, so negative 3 squared, plus 2x, which is 2 times negative 3, minus 3. Do a little bit of algebra. Negative 3 squared, we've talked about this a lot. This is a positive 9. Plus 2 times negative 3, well, that's actually plus a negative, so we'll just subtract 6 and then subtract 3. Okay, well, that equals 0. Let's do the same thing for the 1. F of 1 equals 1 squared plus 2 times 1 minus 3. Well, this gives us 1 plus 2 minus 3. And we can see we got 1 plus 2 is 3, and 3 minus 3 is 0. So what is the relationship then between these zeros of a function? In other words, we put in these values of x and got 0 out, and the x-intercept of the graph of the function. Well, the coordinate, or the x-coordinate, of the intercept, of the x-intercept to be precise, is the same as the value of x that make the function f of x equal to 0. Then it says using the graph in part D, state the x coordinates that satisfy this function. Okay, what are they? Well, we know that if x equals 1 and x equals -3, then 0 equals x squared plus 2x minus 3 is true, meaning if we substitute these in, it will make the statement true. And just another way of saying that comes out of part E. What does f of x equals 0 mean? Well, it means the value of x makes the function equal to 0. So, a new definition, and that's zeros. Well, zeros are the values of x that make the function f of x equal to 0. In other words, you plug zeros into the function. In other words, you plug those x values, and it gives you 0. So anytime we have a value, if you plug into the function f of x and you get out 0, we're going to call those things a 0. And those just happen to be the same values as the x coordinate of the intercept, which makes sense because x-intercepts have a y value equal to 0. Now it says compare the zeros of the function f of x equals x squared plus 2x minus 3 with the solutions to the equation. Okay, well, we know the solutions to the equation is as if we are going to solve for x squared plus 2x minus 3, and we can do that by graphing. We can graph this equation, which we've done up here, and find the intersection. I'm just going to get out my little handy dandy. Oops, wrong line. Let's get rid of that one. Let's make it a solid line. Make it a little thicker. There we go. And we're going to pretend that that's going exactly through the x-intercept. Let's see if it'll do it. Sometimes it won't snap in place. Yeah, it won't snap here. Oh, maybe it will. There we go. Okay. Well, the solution to this is the intersection of the quadratic and the line y equals 0, which just so happens to be also those x-intercepts again. So notice that a solution, while it's related to the zeros, we actually are going to have a new name for that, and that's just coming in a minute. You probably see it down there at the bottom. But the values of the zeros are the same as the values of the solutions. And just to make a difference as to how a 0 is different from this solution, zeros are values you input into f of x, whereas solutions are values you determine that make the corresponding equation 0 equals, for in this case, x plus 2x minus 3 true. And we're going to call these solutions, got another name for you, roots. So roots are the value of x that are solutions to the equation. In other words, you determine roots by solving the equation. And often that means, just like what we did in the activate section, we solved, we isolated the x. That's one approach that we did. We're going to look at other ways a little later on of solving algebraically using factoring as a nice way of seeing these solutions of quadratic functions. So let's fill in the blanks. So let's put it all together. We know that solutions of the equations are called roots. We're going to say the zeros of the function are the same as well, it's kind of the same as the x coordinates of the x-intercepts. But we'll just write x-intercepts here to make it clear so we don't confuse. Of the corresponding graph. So remember, x-intercepts are on graphs. Solutions are from the equation. And zeros of the function are the same value as the x-intercepts of its corresponding graph, and also are the same as the roots of this corresponding equation. A lot to take in there. It's a bit of a mind twist with the use of the vocabulary, but you will get used to it. Just remind yourself, roots are solutions. Zeros are values that make a function equal to 0, and x-intercepts are points on the x-axis of the graph where the function crosses the x-axis. So keep writing it down a few times and it will eventually become clear. So let's start and put this all together to do a few examples. We're going to start by solving the following equations graphically, and we're going to indicate the function that we would enter into the calculator and sketch the graph. And from there, we're going to find those solutions. We're going to find the roots. So the first thing we're going to do is we need to be able to put this into our calculator. And as you know, calculators don't operate with an equal sign in that y equals button. Remember, if we want to put it into the y equals button, it has to be everything on one side. So let's start by making the corresponding function. Well, we would do that by bringing the 8 over to the other side so that f of x, or y, equals x squared minus 2x minus 8. Cool. And that's what we're going to graph. Now, on the graph, you can use your calculator and put it into the y equals button. And when you do, you're going to notice that it goes down and kind of twist off. Oh, this is horrid, but bear with me. There we go. Like that. Now, if we look closely at the graph, and we can do that through the table function, just let me remind you what that is again. So on the graph, we're going to clear this one out, and we're going to put x squared minus 2x minus 8. Now remember, we can hit graph button like this. And here we go. There it is. Perfect, perfect. And we could go ahead and find the zeros using the second trace function to find this number right here, that 2. And we would have to go to the left, to the right, and we would have to do that twice for this one and this one. But the easier way is just go into the table of values and do a little bit of a scroll. Because if we scroll down, oh, there we go. We see the first intercept is negative 2 and 0. So let's just label that here. This is our x-intercept of negative 2 and 0. Now let's look for this one right here in our table of values. Well, that one, keep going up. Oh, there it is, 4 and 0. So now from this equation, we can determine the roots or the solution to the equation of x squared minus 2x equals 8. We can say the first one is going to be x equal to negative 2. And let's verify that by checking the left-hand side with the right-hand side. Now, some people just put left side, right side. I'm old. Left-hand side is what I learned long ago, and I'm sticking with it. But if you use LS, RS, I'm happy with that too. So we know that the left-hand side is x squared minus 2x. I'm going to substitute negative 2 squared minus 2 times negative 2 right there. Well, that gives me 4 plus 4, which equals 8. And sure enough, on the right-hand side, we have an 8. So we have verified that the left-hand side equals the right-hand side. Let's do the other root. The other root is x equal to 4. And let's go ahead, plug those in. When x equals 4, we get 4 squared minus 2 times 4, and we got 8 on this side. Well, 4 squared is 16, minus 2 times 4 is 8. Well, we got 8 there, and we got 8 there. So again, we verified that the left-hand side equals the right-hand side. So these roots make the solutions for this equation. Now let's go ahead and look at the next one. The next one here, we have 2x squared equals 2x minus 3x. Same thing. We're going to get everything to one side. So the function we would put in our calculator is f of x or y equals 2x squared plus 3x. I'm going to put it in descending order. So when I add the 3x here, I'm going to add it here as well and subtract the 2 here and subtract it here. So I'm going to subtract it from both sides. So this is going to give me minus 2. Now when I graph this one, and I won't go through the whole checking the table of values piece, it's going to kind of go something like this. Now we find that this one is still negative 2 and 0, but this one is about 0.5 and 0. And just so you know, we know this because it's in standard form. We know that y-intercept is 0 and negative 2. That's just for fun right there. So what are the roots? Well, the roots are going to be equal to the x-coordinates of the intercepts, which is x equals negative 2 and x equals 0.5. I'm going to just change the color to make my little table seems to stand out a little bit more when it's like red. And I'll make another one over here so we can deal with that one in a minute. And so we got left-hand side. There we go. So let's go to the negative 2, and we're going to make that substitution to verify. Well, we have negative 2 squared minus 2. Oh, sorry, I've gone back to the first one. Let's get rid of that. Let's go and say 2 times negative 2 squared equals 2 minus 3 times negative 2. Let's see if this holds true. Well, negative 2 squared is 4. 2 times 4 is 8. This one here is 2 Minus 3 times negative 2, well, that's plus 6, also equals 8. Left-hand side definitely equals the right-hand side. That's verified. And we're going to do the same with the 0.5. 2 times 0.5 squared equals 2 minus 3 times 0.5 here. Well, 3 times 0.5 is 1.5. In other words, 0.5 is a half, and a half of 3 is 1.5. So this gives 0.5 right here. 0.5 squared, well, that's actually going to be 0.25. And 2 times 0.25 over a quarter, that's back to a half. So the left-hand side also equals the right-hand side in this. So notice that the x-intercepts are indeed the roots of the equation. Let's keep going. Now this one is asking us to solve 0.5x squared plus 3.4x minus 2.1 equals 0 using graphing technology and to round the roots to the nearest tenth. Are you solving an equation or a function? Let's go look at that. Well, the first thing we want to do is enter y equals 0.5x squared plus 3.4x minus 2.1 into the calculator. So let's go ahead and we're going to do that first. Okay, so I've entered in the equation in my y, 0.5x squared plus 3.4x minus 2.1. And when I look at the graph, sure enough, I can see there's two roots here and here. Now this one, if I go ahead and look at my table, I'm going to notice that I'm not going to be able to find any zeros by scrolling. There's nothing here. Notice all these decimal values here. So which is a pretty good indication that these decimal value or these intercepts right here are decimals. So let's go ahead and we're going to use the second trace 0. So number 2 for 0. So the first thing, we're going to go a little to the left of a 0. So this point right here, this is to the left. If I drew a straight line through that x-intercept there, that one is to the left. We hit enter. Notice the y value is negative. Now we're going to keep going left. It actually is now above the x-intercept, so now the y value is positive. That's what you want to see. You want to see a switch in the sign of the y value, either from negative to positive or positive to negative. So we hit enter, and notice we get the two arrows pointing at each other. Hit enter again, and we see that when y equals 0, the root or the solution is x equals, looked away, 0.57, because we're going to round to the nearest, round to the nearest tenth. Oh, let's do that again, 0.57, and let's write down a few more. I have a great memory, it's just short, 0.56988. To round that to the nearest tenth means x equals, the tenth is this position right following the decimal. So we have to round. We look at this one, it's a 6. The 6 means it goes up, so it's 0.6. Okay, let's do the next one. Second trace, 2 for 0. Now we got to scroll over. We're going to scroll till we're to the left of that next intercept. Now, notice this one is headed downwards. So that means we have to start with a positive y. Okay, so we hit enter, and then we go to the right until we get the negative y. Now we get a negative y. hit enter, and we got x equals -7 point, and rounding that to the nearest tenth is a 4. Okay, so we got 0.6 and -7.4. Now it's asking us, are we solving an equation or a function? Well, we know we're solving an equation because we determined the value of x that made the statement true. And then, well, in this case, the values of x that made the statement true. So I want you to try a few things. I want you to go ahead and head on over to solving equations graphically. That is the practice questions. I want you to try questions 1A and 3A. And because you're an asynchronous student, or maybe you're a synchronous student working from home today because you're not feeling so great, go ahead and do them, check your solutions, and then show the work and send it to your teacher in an email. Well, let's move on. So in this question, we got a little bit of an application type question, problem solving. It says a soccer ball is kicked and its path is described using the function h of d equals 0.5 x squared plus 2.6, where h of d is the height of the ball and d is the horizontal distance the ball travels. Height and distance are measured in meters. So let's look at what we have here. We're going to go and I'm going to make a quick sketch of what this is. Well, I know just by looking at it, there is no y-intercept. In other words, the y-intercept is 0. So it's going to start at this point here. It's going to come up because it's kicked up in the air and come back and land on the ground. The question asks, what does h of d mean? Well, d is the input value and h of d is the output value. In other words, d is the x, h of d is the y. Well, when h of d equals 0, what it means here is the horizontal distance, because h of d is the horizontal distance, the horizontal distance d that makes the height equal to 0. So the horizontal distance d that makes the height, well, we can call it the height is h of d, equal to 0. Or in other words, that's a bad word, 0. There we go. It tells us when the ball is on the ground. And that makes sense. If the ball is kicked, it's on the ground to start with, it goes up in the air and then lands on the ground again. Next question is, what horizontal distance does the ball travel before it hits the ground? Well, the horizontal distance from here to here can be determined if we knew this x-intercept. So let's go ahead, plug it into our calculator, and see what we get. So we go in here and we get, turn it on, we get y equals there we go, negative. Now let's put the negative here, 0.15 x squared plus 2.6. And if we graph that, we do it wrong because I forgot the x. There we go. It's like, why does it have an x-intercept? Now notice I'm not getting the whole graph. So let's go change some window settings. I notice this goes from 0 to 10 right here. And because we kicked the ball, it doesn't make sense to talk about it started at -4 meters. So I'm going to change the window setting so my x min is 0. My x max is about, let's say 20. And then I'm also going to change my y max to 20. And because it can't go below the ground, I'm going to put 0. Actually, change my mind. I'm going to put about -5. And I'll show you in a minute why it's a good idea to do that. So I'm going to hit graph. Let's see. There we go. That's nice. Now, the reason I wanted to go a little bit below is I want to find this intercept. First thing, do a quick table search here. And because I'm up in, almost 20, I'm going to look and see if I can find any values before 20. No. See, now they start going negative again. So the x-intercept doesn't show up here. So that means when I look at this graph, I have to go second, trace. And I'm going to put a 2 for the 0. I'm going to get close. Now, if you made your y minimum equal to 0, you would be able to do the first point and get the first arrow, but you couldn't go below. So sometimes it's hard to see, and you want to make sure you're definitely below. There you go. And we get that. So the value of x when the soccer ball is landing back on the ground, or the horizontal distance. So the horizontal distance traveled is equal to, and again, great memory, just short. We're going to go to the nearest tenth, is 17.3 meters. There we go. Let's keep going, and we're looking at the last question. Now, this is a common question type. And before we get into it, we have to make sure we understand what a few of these words mean. The first one is consecutive. The consecutive means that it is one number right after the next. But in this case, it's even numbers that are consecutive. For example, if I wrote 2, 4, 6, 8, these are even numbers. For instance, 2 and 4 are consecutive even numbers. One follows the other. 6 and 8 are consecutive even numbers. 4 and 6 are consecutive. But 2 and 6 are not consecutive because the 4 is between them. So we are looking for consecutive even numbers. that have a product, and we know product is multiply, but in this course, we're using a dot because we don't want to mess it up with the x's. Now, the first question says, an even integer can be expressed algebraically as 2x. That makes sense because if x equals 1, the first integer, which is even, is 2 times 1, which is 2. If x equaled 2, the next integer is 2 times 2, which equals 4. And so forth and so on. We can keep doing this all day long, and it would just keep giving us the next even integer. We can even go backwards, and we could say x equals -1, and that would give us -2. We can say x equals 0, and that would give us 0. X equals negative, say, let's go to -2, and we go to -4. And now putting these in order, it would go 0, -2, and then -4. So as you can see, we need to put that 2 in there because as the x goes in, it will always spit out an even number because even numbers are just multiples of 2. Now, let's write an expression for an even integer that is consecutive to 2x. What do I have to do to 2x so that I get the next even integer? Well, that goes back to our group of 4 up at the top there. What is the difference between each number? Well, it's 2. It's like we're adding 2 every time. So the same thing goes here. I can say we're going to add 2, and that's the next integer. And in particular, the next even integer. Part C. Write an equation that could be used to find the two integers. Well, we know that if we multiply them together, the product has to equal to 288. So 2x, which is the first one, times 2x plus 2 has to equal to 288. This is an equation. We can FOIL or distribute this out, and we'll get 4x squared plus 4x equals 288. Again, it's an equation. We need to find the value of x that makes the statement true. In other words, we're looking for the roots. Now, to solve this graphically, we need to put y1 equals to 4x squared plus 4x minus 288. Because I want to bring everything to the other side. So I'm subtracting 288 from both sides. Now I'm going to go second, trace, and we're going to go 2 for 0 if you're on the TI 83 or 4. Or we can use the table of values. Now this one is kind of nice because we have to scroll a little bit, but we can find if we scroll that table of values, and I won't do it here, I'll let you do that. We find that one of the x's that makes the statement true, or the x-intercept, is 8 and 0, so 8. The other one, the other solution, the other root, is -9. And let's check it out. Let's see what it is. Well, if x equals 8, then 2x equals 2 times 8, which equals 16. That's one number. The other number is 2x plus 2, and 2x plus 2 is 16 plus 2, which is 18. Well, let's see what happens when we multiply 16 by 18. Well, sure enough, we get 288. Well, let's look at this second solution. We got 2 times -9. Well, that equals negative 18. Well, the next solution would be 2x plus 2, or 2 times negative 9 plus 2, and that equaled negative 16. Well, and these are also consecutive. And if we multiplied those together, look what happened here. I mean, they're the same numbers. Here we have two positive numbers, 16, 18. Here we have two negative numbers, and they're still going to equal 288. So explain why there are two sets of integers. Well, there was two values of x. One solution gave the positive pair, and the other solution gave the negative pair. Well, that brings us to the end of our lesson, and it's now time to see if you've mastered some of these skills. Go ahead and take some time to do as many of these practice questions as time allows. If you're having trouble, make sure you're getting in touch with your teacher. They would love to hear from you. That's the end of our lesson. I hope you have a great rest of your day. Take care.